back. In this video, we'll be learning how to find the function from the derivative and a point given on the line or on the graph. So this is where you'll get to learn how to calculate the exact value of c that we've been adding at the end of each integral. Let's look at an example here. So we said that if you had differentiated either of these functions here, you would have ended up with 2x. No matter what, both of the derivative of x squared plus 1 and x squared plus 5 would have given you 2x. So we wouldn't have known whether the derivative that we have 2x, which did it come from the top graph or the bottom graph, or it could have come from any other graph that is in this on this curve. Okay, well, similar to x squared. As long as it had the x squared in it, that's what we're sure about. So when we integrate 2x, we write as x squared plus c. So to actually evaluate and figure out whether it was the top curve or the bottom curve, we need a point on the graph to evaluate and calculate the value of c. A point means it's x and y coordinate. So as long as you have one of those x and y coordinates, then you can find the y-intercept, and that's the value of c. Alright, so in this example, we've been told that f dash is 5x squared plus 3x, and the original fx passed through 2, 15. Therefore, what we do is, as we did in previous examples, we integrate this derivative function, so we end up with example. So x squared became x cubed and so on and so forth. And we put the plus c at the end in front of it. Then now we substitute that 2 for x, and instead of f of x, we're going to take that 15 because f of x stands for y, doesn't it? So we say 15 equals to this with a c. Now everything here is we got rid of the y's and x's or f of x and x's, and there is only one unknown, that is the value of c. You solve this like an equation. You say, all right, let me simplify everything. These fractions, maybe I can add them together and subtract from the right and left. This 19 and a third, if we take that away from both sides, we end up with a negative 4 and a third. So c is negative 4 and a third. So we write it as like so. Notice that this line here is just that line there, with c replaced with negative 4 over third. Okay, so let's have a look at yet another example. In this case, we will integrate this function here. We can rewrite it first of all as 3x to the power 3 over 2 minus 2 times x to the power minus a half, and so that integration will be easier. So once you integrate that, we're still rewriting the same expression for derivative. Now we are integrating, so it means adding 1 to the power and dividing by the new power, and we wrote c. Now we stop and we substitute 4 for x in this expression and 5 for f of x. And to calculate the value of c, of course, we end up with, we are still substituting, yes, we haven't still substituted. Now we are substituting x equal to 4 and y equal to 5. So we solve this expression for c. Now evaluate this carefully on a calculator. That means 4 square rooted and then raised to the power of 5. So that becomes 2 to the power of 5, which is 32. 32 times 2 fifths and minus 8 plus c. Now take these two numbers that are next to c away to the other side. C is 1/5. Therefore, we write our function that we integrated. Rather than a plus c, you're going to write Write it again, but replace c with 1/5. Now, this is the exercise, and I hope you get good practice. I'll see you in the next video.